Ooh, where is it?
Yeah.
All right, so let's take a look here. We're really just going to concentrate. We're going to do double angle identities today. We really don't cover the power reducing identities, and then you got the half angle identity. So if you look at your identity sheet, you'll see the double after the sum and difference on that right hand side. You'll see the double angles in the middle, and then down below the half angles. All right, so they have this handy. It's just better to refer to that. A couple things here, plan wise. Tomorrow, so Tuesday, we're going to do one of those 10-point trig quizzes, and that's going to be formative. And then Thursday, we're going to do the big one. It's going to be a 40-point trig quiz, summative. Okay, it's just going to be the same type, except there'll be 20 questions. Okay, so sine of pi over 2, cosine of 330, all that stuff. So 40-point trig quiz, summative. Okay, so that'll count as an actual quiz, like CCP, not as a homework one. And then I think next Thursday, if I remember right, we'll have the chapter 6 test. So we'll start 6.3. We skip 6.4.
How much time do we get for Thursdays?
Usually I'm going to give you about 15 minutes. If you need a minute or two longer, I'm not going to cut you off. Okay. I mean, that's 20 minutes max. I mean, we're not going to go past that. All right. But most people are done in plenty of time on that. So it's typically 15 minutes. If you need a little bit extra, that's fine. But 20 max for that. But that'll be 40 points. And then, like I said, there'll be 20 questions on that one. 2 points each for that. Okay, the other one's 10. And the next Thursday, chapter 6 test. Okay, so that's kind of the agenda moving forward. All right. Now, like I said, we got double angle identities. We're going to prove a couple of these. Actually, the first two. I'm going to go through. So at the top left, see where it says sine of 2 alpha equals 2 sine of alpha, cosine alpha. Under there, we're going to prove that. Well, we're going to you're allowed to use anything above it. So you can use all the sum and difference formulas, and you can use anything to the left. Okay, because we've proven all of those at some point, or we've justified those at some point. Now, this is just on the side here. X plus X equals what? 2X. Not a trick question. So alpha plus alpha equals 2 alpha. So what I'm going to do is I'm going to take the sine of 2 alpha, and I'm going to write it as the sine of alpha plus alpha. I am now adding 2 angles together, which is on the formula sheet. So you can go to, this isn't necessarily, this is just explaining where it's coming from. We can use the sine of alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta, right? That formula. We're going to use that. Well, instead of using alpha and beta, we're going to use alpha and alpha. So it's going to look like this. It's going to look like sine alpha times cosine alpha plus cosine alpha times sine alpha. Well, those are the exact same things. Okay, I can reverse the order there, and now it just becomes 2 sine alpha cosine alpha. So that's all you got to do for that. 2 sine alpha cosine alpha. And we're using that sum formula, but we're just using the same angle twice. Okay, same angle twice. Now, if you look at the identity sheet, how many formulas are actually listed for cosine of 2 alpha? there are actually 3 of them listed. Okay, so you can use any of them at any time. And you also, that second one is also says cosine squared minus sine squared, so you got to watch out. Don't think that's going to add up to 1 or anything like that. It's a little bit different. So for cosine of 2 alpha equals cosine squared alpha minus sine squared alpha, we're going to do the exact same thing. So start with cosine 2 alpha, write it as the cosine of alpha plus alpha. And it doesn't really matter which one you use. I'd probably use the one on the right. If you've already started with a different one, that's fine, because you'll see they're really the same. So cosine alpha plus alpha. Now, I'm going to use that formula. What's it say in here? Okay, so it says if you're adding 2 angles, you take the cosine of the first times the cosine of the second. So it's just going to be cosine alpha times cosine alpha minus sine of the first times sine of the second. Well, cosine alpha times cosine alpha is cosine squared minus sine squared. All right, that's all. So we're just using something we already know. Now those 2 below it, I'm going to show you how to get the other 2. We're going to actually start with that. So we just proven that. And so we're going to split off here. And we know that cosine of 2 alpha equals cosine squared alpha minus sine squared alpha. So down there, one of those left, you already got that written down. All right, what does cosine squared equal? What can we replace that with? Cosine squared equals 1 minus sine squared. So I take out cosine squared and I put in 1 minus sine squared. Now I got 2 sine squared, so I got 1 minus 2 sine squared alpha equals cosine 2 alpha. Now that's one of your other formulas, right? That's the second one down. So I'm down below there on those other 2. So I'm like using those 2. So you can kind of start from there. Yep, right there. And now you have 1 more there, and so we're done with that one. So go below there where it also says cosine 2 alpha equals cosine squared alpha minus sine squared alpha. Since we already proved it, we can use that. Now instead of replacing cosine squared, what do we got to replace? Replace sine squared. So replace that with 1 minus cosine squared. Now here's what you got to watch. Some people tend to forget this. You're still subtracting. When we substitute in a binomial, you got to put it in parentheses. You got to distribute that negative sign. So this now becomes cosine squared alpha minus 1 plus cosine squared alpha. And so when I'm done, I get 2 cosine squared alpha minus 1. So these are all equivalent. Okay, those are all equivalent. And let me just make this cosine 2 alpha. And it doesn't matter which one you use. You're still going to come up with the same answer. Either 1 minus 2 sine squared or 2 cosine squared minus 1 for those. Now, we're not going to prove the tangent one. And that one is just already on your identity sheet, but I'm just putting it up here. Tangent of 2 alpha is 2 tangent of alpha, 1 minus tangent squared. Okay, we're just going to prove the cosine and the sine. All right, let's take a look at an example that uses it. Okay. If tangent of theta equals 5/12, okay, make sure ours match up. Theta's in quadrant 3. Find what the sine of 2 theta is, what the cosine of 2 theta is, what the tangent, and we'll do these together. Okay. So now it's in quadrant 3. It's positive 5 over 12. Which means opposite is 5, adjacent is 12, and we got to find that R value. So I'm going to do 5 squared plus 12 squared equals R squared. 25 plus 144 is 169 equals R squared. R equals square root of 169, but make sure that you test it to see if it comes out to be a whole number. We don't want to use that if it's going to be a whole number. What's the square root of 169? 13. So it's 13. So that's 13. Okay, sine of 2 theta. Would be 2 sine of theta times cosine of theta. So it's going to be 2. Well, what's the sine of theta in this case? We're in quadrant 3, so sine has to be negative. So sine of theta is going to be negative, opposite over hypotenuse, negative 5 over 13. Cosine of theta, since we're in quadrant 3. Okay, theta is still in quadrant 3. Cosine of theta is going to be negative 12 over 13. Now just watch your algebra here, or your arithmetic. Go ahead and multiply those together. I'm going to pull up my calculator here because I don't have it. All right, so you take 2 times negative 5 times negative 12. So you're going to end up with a positive. 2 times 5 is 10. 10 times 12 looks to be 120. 13 times 13 is 169. I don't think that reduces. Double check that for me. Looks like I get 120 over 169. Okay, so that's the value of it. So the sine of twice the angle. Okay, so if you would, wherever that angle is, you double it, you'd take 120 over 169. All right, cosine 2 theta. You got 3 options to choose from. It really doesn't matter which one you use. It makes no difference. You got to get the same answer regardless. I'm just going to use the first one. Cosine of 2 theta equals, I believe it's cosine squared minus sine squared. Yep, you cannot flip the order either. You got to watch that. Cosine squared theta minus sine squared theta. All right, what was cosine? Cosine was negative 12 over 13. Now you got to watch, that's being squared. Minus negative 5 over 13. It's being squared. Negative 12 over 13 squared. Make that 100 positive 144 over 169. Minus the negative 5 squared. Okay, you can't take that negative times a negative because you got to square it first. Okay, you got to make sure you do that. So that minus will stay. It becomes 25 over 169. And now cosine of 2 theta will equal, what do we get there? 144, 34, 20, 119 over 169. Okay, so we got sine, we got the cosine, and now you got the tangent. All right, what's our equation for tangent? We got tangent. I'm just going to use the theta instead of the alpha. I got 2 tangent of theta over 1 minus tangent squared. All right, so let's take a look at that and see what we come up with. And I get 2 tangent of theta, we already said was 5/12. I believe so. I'm going to double check. Yep. 1 minus 512 squared. Okay. Let's see what we get here. Equals. Now 2 times 5/12 is 10/12. Some of you reduce that to 5/6. You can leave it as 10/12. And I get 1 minus 25 over 144. I'm going to reduce that to 5/6. All right, what's 1 minus 25 over 144? Okay. Well, 1 is 144 over 144. So if I just subtract 25, I get 119 over 144. Now that becomes 5/6 times 144 over 119. All right, make your life just a little bit easier. Does 6 go into 144? Test that, or at least 2 will go into it. Does 6 go into it? How many times?
24.
24. So if I take 144 divided by 6, it's 24. So that means I can reduce. So that becomes a 1, and that becomes a 24. And then what do I get there? I get, so that's going to give me tangent of 2 theta equals 5 times 24. What is that, 120? 120 over 119. Okay. All right, now I know I didn't leave you room. If you want to throw this on the back, you can, or you can just pay attention. There is a separate way to do this. Tangent of 2 theta is the same as the sine of 2 theta over the cosine of 2 theta. Yes, you can use that. Okay, some of you might have recognized that and said, hey, can I do that? Yes. The tangent is always equal to the sine of the angle over the cosine of the angle. Well, we already figured out the sine of 2 theta. All right. Gavin, what was our answer for the sine of 2 theta?
120 over 169.
Okay, it was 120 over 169. Hey, Wendy, what was our answer for cosine of 2 theta? So 119 over 169. So that is going to be 120 over 169 times, flip, make it 169 over 119. Cancel those 169s, and we get 120 over 119. Same thing. I don't care which way you do it. Now, if I just ask you to find the tangent of 2 theta and you haven't found the sine and cosine, then you're kind of, your hands are tied. You either need to do all of that or just go right to that formula. But it really doesn't matter either way. So if given a case, make sure you watch your negatives. Okay, watch sure where you're squaring, and then reduce as needed. Now, there's something else that we come up across in double angle identities is find the exact value. Anytime you see the word exact value, okay, you can't just type it into your calculator and write a decimal down. You got to come up another way to come across it. All right, cosine squared of 22.5 degrees minus sine squared of 22.5. Yeah, you can get an answer on your calculator, but that's not what we want. Cosine, let me see here. It's a little bit harder to do the squared. And so you almost have to do parentheses around. You can't square this point here. You actually have to do this. Cosine 22.5 squared. Okay, that'll give you that. Minus, I'm just seeing what's going to pop up. Sine 22.5 squared. All right, so that's the decimal. That's obviously not what we want. All right, any ideas how we can do this? Where on our identity sheet do we see the form cosine squared minus sine squared? What's that?
Cosine 2 alpha.
Cosine 2 alpha. Cosine of 2 alpha is equal to the cosine squared of alpha minus the sine squared of alpha. So in this case here, what is our alpha? According to this, our alpha is this angle right here. Our alpha is 22.5 degrees. Okay? And now we're saying that cosine squared minus sine squared is equal to cosine of 2 times 22.5. Well, that's going to be 2 times 22.5, which is what? Cosine of 45 degrees. Got to be able to figure that out. Without your calculator, what's the cosine of 45 degrees? Take a second. Radical 2 over 2. It's in the first degree, or first quadrant. So radical 2 over 2 would be that answer. Now, if I go to my calculator, I had second square root of 2 divided by 2. I get the same decimal as I did when I did cosine squared 22.5 minus sine squared 22.5. So that kind of validates my answer. Okay, so you can test it, you can check it, but you got to be able to come up with radical 2 over 2. All right, so how do you think we do this one? 2 tangent of 5 pi over 12 over 1 minus tangent squared 5 pi over 12. What is that equivalent to? Okay, Eddie? Tangent of 2 times the angle, so it's equal to the tangent of 2 times 5 pi over 12. Okay? What is the tangent? Now, what is that? That is the tangent 2 times 5 is 10. So I get 10 pi over 12. That reduces to 5 pi over 6. All right, this is a good practice for tomorrow and Thursday. See what that is? What's the tangent of 5 pi over 6? See if you remember where that is and how to calculate it. And make sure you always double check, is it positive or is it negative? Okay, is it positive or is it negative? All right. Max, you got it? What do you think?
Is it square root of 3 over 3, negative square root of 3 over 3?
Negative square root of 3 over 3. Okay, that's tangent 5 pi over 6. 5 pi over 6 is in quadrant 2 because it's 150. 100 pi over 6 is 30, so 5 times 30 is 150. So it gives me this angle right here is 30 degrees. Think about the unit circle. So opposites 1/2, adjacent's radical 3 over 2, which technically is negative. Okay, whether you use the negative now or just it's going to be negative later, either way. So you take 1/2 divided by square root of 3 over 2, which is 1/2 times 2 over radical 3. Cancel those 2's. 1 over radical 3, which is radical 3 over 3. And we said it's going to be negative because it's in quadrant 2 for that one. So you got to take a look. All right, you got to say, all right, that looks like one of my identities. Which one does it look like? Well, it's tangent of 2 times the angle. Cosine squared minus sine squared. Okay, that's cosine of 2 times that angle. So you got to take a look at that one. All right. Not a long Monday here. Just to give you a little bit of time. On it. Some of these have parts. You got to find more than just one. So 9, 11, 13, and 15 through 18 all. 10 question quiz tomorrow. If whatever you missed on the quiz, if you can't figure that out, I can help you now, just kind of clean anything up on that quiz as well.